Hi everyone. So in this video I'm going to talk about a very simple method using which you can incorporate the sales of high seasonal peaks or peak seasonality into later months. So this is going to use the concept of logistic decay function. So decay is basically going to give you the lagged effects of peak seasons. So for instance, if you have Black Friday or Christmas related sales or end of the year sales, these can then have a lagged effect on further months, on the following months, say in January, in February, in March, and even up to say April or May. You may have still effects of those seasonal peaks actually getting recorded or having their impact reflected in those later months. So how do you actually account for that within Google Ads? You can of course adjust your seasonality, but how much would you be adjusting? So Google Ads, for instance, provides the seasonality adjustment as a percentage, as you know, depending on how much you expect. That expectation can actually be mathematically justified. That can be mathematically you can actually come up with that proper number. There are many ways of doing it, several ways of doing it, but one very simple way, so I came up in this came across this concept actually in a Google account where they were doing this very nicely. So they basically use the concept of logistic decay function. So that actually looks like this. So it's a decay function, as you can see, that over the months that as the months progress, the effect, the lagged impact sort of decreases. So this is actually arising from this particular table. This is dummy data. So suppose in the first month, suppose, and by month 0 is meant the month of the peak season. So suppose it was October. So in the month of October you had suppose you started with sales of say £100. So how much of that £100 will still sort of have lagged versions of it in the following months? So you will still have say £53 in the next month, and £23 in the month after, 9, 3 and 1, like that. It's going to have lagged impact. And this is important because this is taking into account what in causal inference terms is called selection, is called selection bias, because this means that this amount of sales would have happened anyway because of the seasonal peak that actually happened, that actually took place during that specific month, say in this case October. So suppose you're looking at October, November, December, January, February. So let's look at October, November, December. So suppose in December, of course these are looking like small numbers just for ease of understanding, but in reality this could be multiplied. You could have in hundreds of thousands. In reality that can have a major impact on your analysis. So suppose in case of in these numbers, if you're looking at December, you will still have say 23. Maybe 23 into 1,000 or maybe 23 into 100,000. That amount of sales has actually arisen out of a lagged impact of something that was happening a couple of months back. So you should be taking that into account as sort of a selection bias, because you're essentially introducing a bias into the system. If you think that your entire sales is because of current marketing activities, that will be a wrong decision. So you will have a better understanding, a better ability to draw a judgment, to come to a conclusion about marketing efficiency if you take this lagged impact into account. That is the whole point. And how do you do it? You first of all do this analysis. You start with your lagged impact number at month 0, and then you sort of introduce this logistic decay function here. As you can see, this has been defined here in this function. So this is how it really looks like. So if I just scroll down a little bit, this is basically the logistic decay function. As you can see, there is an exponential component here in the denominator, and so the way it works is that this sort of as this increases, the denominator increases, the value decreases, which is why your decay effect constantly decreases over time. So the major factor here is the decay rate constant. So this basically determines how fast that particular decay is going to happen. So all of this has been taken into account, into this Python code, the computation of decay weights, the calculation of the lagged impact. As you can see, it's the initial sale into normalized weights. So I'm just going to come to an example here to walk you through that, to sort of give you an understanding of the code. So so then there are two important points here: the maximum value, which is usually set to 100%. So we'll for all our purposes we'll just set it to 1. the decay rate constant and the inflection point. So that is the point where it actually transitions most rapidly. So there's usually a point where this starts transitioning very fast, where it starts decaying quickly. So that is called the inflection point. And apart from that, there's the decay rate constant. So these are the two most important elements of the logistic decay function. And this is essentially a decreasing sigmoid curve. So there's a very close relationship between the sigmoid function and the logistic decay function. I'm not going into that, but just to sort of give you some context. And you can see there is a concept of normalized weights here. So you will have weights and you will also have normalized weights. So if you look at the raw decay weight here, so this raw decay weight, these weights, by the way, have been determined from this logistic decay function. So that is how you come up with the weights. And once you have the weights, you do a normalization, which is simply based on the first month, which is month 0's weight. So this is basically 0.53 is obtained by doing a ratio of these two. So if I just go down here, you'll see that it's ft by f0. So for instance, if I come to this interpretation here, example interpretation, you'll see that at L equal to 1, K equal to 1, T is equal to 0, an initial sale of 100. So at T equal to 0, you just put in 0 here in E's power. So f of 0 is 0.5. So that gives you your lagged weight essentially. Or the raw decay weight. And then the normalized weight, after you calculate f0 and f1, is simply the ratio of these two, 0.26 by 0.5, so 0.5378. So if you look at that table here, that's how you achieve all the weights. And once you have the weight, it's simply multiplied by the initial value of the sale. So 100 into 0.53 gives you 53, 100 into 0.23 gives you 23, so on and so forth. So it's a very simple idea, as you can see, but behind it is an important mathematical concept of logistic decay function that I just wanted to point out. It's an idea that you can build into the system, and it sort of gives you a very nice way of presenting as well. So you can, for instance, if it's t0 equal to 0, so t0, remember, is the inflection point. That is where the maximum change happens most rapidly. So you'll see that this was decaying at this rate, but after that it completely transitioned, right? So this was the slope of the curve has completely changed, as you can see, after this point here at t0 equal to 0. So again, just to understand how the different k values of the decay rate, the decay constant, how that actually has an impact on the curve, you can see it with k equal to 0.5, 1 and 2, how again at t0 equal to 0, how it has different kinds of shapes basically, and how so with k, so the decay rate constant, the higher they are, the more will be the the faster this will decay essentially, because as you understand, k is in the denominator, right? So, and it's the power of the exponential, so it's going to have an exponential impact, which is why the change happens so rapidly. So this is what you would actually also expect in reality, that the decay will not be so gradual. It will probably be pretty fast after a point. I think most marketers will probably agree with that. And by decay, again, I mean the effect of some some seasonal impact, some sort of major event that took place several months back. So if you want to really incorporate that effect, you will probably look into some sort of a decay function of this nature. Again, this does not have to be the only way to do it. There can be other mathematical ways of doing it, but I'm just giving an idea how you can do this. In this case, specific case, I have used the concept of logistic decay function. It could have been any other function that you might have felt would have been more ideal for this. This again is the different inflection points, by the way. So t equal to 0, we saw that t0 equal to 0 is the orange one, in the middle one, as you can see, but in some other cases, this is where it started. It has started at -2, and this one has started at 0.2. So that is where the curve actually shifts directions. As you can see, the slope completely changes. So again, lower k, the curve decays more slowly. Like I said, higher k, it decays more sharply, and negative t0 shifts the curve left, positive t0 shifts the curve right. So just to give you an understanding of how different values will impact it, and depending on that, you might want to update your function accordingly. So I mean, this was just the rudimentary idea. Like I said, you can use this information now. You can use these percentages to come up with your seasonality adjustments, that how much do you think, how much weightage do you think every month would have after a particular seasonal month. And then again, you might have to go into cascading. Remember, you might have to club together different weightages and then come up with an aggregate weight for a particular month if you have several seasonal effects. Suppose you don't have only one seasonal factor, right? So this is a very interesting way of incorporating seasonality, right? So that was the most interesting thing for me, because seasonality usually is done through other methods, like through time series analysis or through seasonal decomposition, ACF plots. Those are relatively more complex and requires a data science resource, but this is something that you can get started as a marketer. If you need any other kind of mathematical approach to it, do let me know. I will help you out with that. But yeah, this was it. Hopefully this was useful. Like always, do let me know in your comments if you have any questions or thoughts, and I'll see you in the next one. Thanks for watching.